Hello Aniruddha, good evening. Can you hear me?
Yes.
Yeah, okay. Yeah, good evening. So, did you solve this week 11 assignment? How it was? You have any difficulty in that?
11 was done. Now I'm doing 12 talk.
Okay. Yeah. So, just a
I think the voice is a bit
second. Yeah,
not that audible.
just a second. I'll just confirm this. Okay. Just I'll change the microphone. I think now it will be audible for you. Yeah. So I was asking whether you have any problem in week 11. We can discuss about question by question, or in week 12 also. We'll go by that also.
Week 12 also. There were some doubts I had with the, like, I
Ah,
didn't understand that
okay,
mode locking and their effect.
okay.
Question by question is also.
So week 12 you want to discuss. Which question you are talking about?
Week 11 is also fine, sir. That from the revision also.
Okay. What? 11 is also okay.
Yeah, 11, I think, then do it.
Yeah. First we'll go by 11, then we'll go to 12. So in this, the first question is a linearly polarized optical wave travels along the direction of the optic axis parallel to electric field. The appropriate parameters for the phase modulator are R is given 9.6 picometers per volt. Then N naught is given 2.3, lambda is given 633 nanometers, and find the half wave voltage. It's given here. Okay, so all these values are given, and the uh, equation for this will be like half wave voltage is V pi is equal to lambda d upon r n naught square L. So if we'll put each and every value here, you have to think about this um, nanometer and picometer. All these things should be in a particular one unit, and you'll get one value that will be like x dot yy into 10 to the power 3 volts. So how much for you? How much it is coming? Can you tell me?
0. Not 0, 5.4.
5.4. Okay, yeah, it's correct. The range is around 5.38 to 5.43. In this in between this it should come. Okay. Now question number 2 is there. 1064 nanometer pump laser is used to generate a 532 nanometer signal in a non-linear optical medium. The signal is then amplified by a parametric amplifier. Which of the following statement is true about the amplified signal? So here, can you tell me what should be the answer?
So this one I didn't understand the answer. The answer they have given was between 32 nanometer and they put as the other than 532 or
So
1.
what you could have guessed? First tell me that one.
the last of
Uh-huh.
than other than 532 or 1000.
Okay, you okay, this one, okay. Just let me check once. Okay, so what is happening here? This 1064 nanometer pump laser is used and generating the 532 nanometer signal in a non-linear optical medium. Okay, suppose okay, so what is happening in non-linear? There will be virtual state and here also one virtual state. Okay, so 1064 nanometer wavelength it is exciting and it's emitting 532. It's generating 532. Now the thing is like the signal is then amplified by a parametric amplifier. So in parametric amplifier what is happening? It is this frequency will be there some or different will be there. Okay, in the frequency, the new generated frequency. It will be like the difference of sum also we can say this side.
If we take the sum of then
Okay, here signal wave. Okay,
so
so we have to
we
do,
can
I
also
think.
sum of frequencies. So then it can be other than 832 and 1064. I thought that will be the bonus.
Yeah, wait, I'll just solve your doubt. Thing is like
Yes.
this frequency is a pump frequency. Okay, first of all, this pump frequency and a signal wave, whatever is we are getting. So sum of that, we can't just add these frequencies together. Okay, like you are thinking like this now, 1064 plus 532, and the difference also we are thinking like that. Are you thinking like this?
Yes, third parameter. Okay.
Yeah, but the thing is here you have to convert this one frequency into wave number. After that you try. Are you
So
getting my point?
why do we have to sort it way now?
Actually frequency we can't just add and different. Okay, suppose it's like a, you have to convert into a quantitative number. Per nanometer it will come.
Oh, okay.
Then you just add this. Okay, first frequency and second frequency. For this also you do same. Are you getting my point?
Yes, but
Yeah.
this is the if possible
Okay,
if you can
just
follow
second. Yeah.
for the fourth because
I
it's
think you are,
definitely not
no.
normal.
What you are telling?
It is it is amplified at a different level.
Okay. Yeah. So wave number we have to do. Just second, I'll check this answer what they have given. Give me some space, please. Someone is on. Someone wants to join with me. Good evening, sir. Can you hear me, sir?
Yeah.
Yes, yes, Anthony, I can hear
Sir,
you clearly.
actually we have stuck in this question number 2 of week 11.
Right.
There is a one option. Anirudh is telling that this should be wavelength other than 532 or 1064. So can you?
So like both options can be true, master, because little bit angry.
So you have a 1064 nanometer pump laser used to generate 532 nanometer signal in an ordinary option. The signal is then amplified by a parametric amplifier. Which of the following statements is true? Look at this. Don't worry about 1064. You already have generated 532. Right? So that 532 nanometer is what is actually entering this parametric amplifier. So what amplification mean? What radiation will still undergo that amplification? That's what you have to look at. Okay, so the 532 nanometers already generated. Now it's entering a parametric amplifier. Now what will be seen at the out? Hope that's clear, Anirudh.
Yes, sir. Yes. That parametric amplifier, I think I have to go over it again. Little bit.
So that parametric amplifier can basically amplify the 532 nanometer. Yeah.
Thank
So I actually logged in for a little bit just to address those who joined here and those who are going to be listening to this recording. Nikud, this is actually assignment 12, is it?
No, sir. Actually, assignment 12 is live, so I'm here addressing about week 11.
11. Okay, fine. Yeah. So you are actually, the students are going to be looking at 12 now,
Yes.
and just in a few days, they will have your final exam. And I'm sure several of you are anxious about it. I wanted to just let you know that the final exam is going to consist of two parts. The first part is going to be, questions very similar to like multiple choice and match the following and some numerical questions that we have been looking at the tutorial. Now part B is going to consist of the design of a system, like for example an optical communication system. So when you think about an optical communication system, you will have something called a transmitter, and which may actually have a laser as well as a modulator, and then you will have the optical fiber itself, which is the transmission medium, and then you will have the optical receiver. Now, although it looks like it's a big system, we'll have one set of questions related to the laser, one set of questions related to the modulator, one set of questions related to the fiber, and another set related to the receiver. Now, under each of these questions, what you're likely to find is some common parameters that are given. and based on those parameters, you need to answer a common set of questions. Okay. So these questions are not going to be any different from what you have already been practicing or what you already been taught in these assignments. For example, in I think assignment 11 also there is one question which has some common data, and then there are 2 or 3 questions based on that common data. So you'll have similar sort of questions this concern. And so what I want you to make sure that you don't get confused by that. Although it is talking about design of a system, I'm actually breaking it up into individual questions, and those individual what you would have are very similar to what you would have seen in say week 5 when we were talking about lasers, or week 3 when we were talking about optical fibers, or week 8 when we were talking of vectors, and so on. Right? So it will be like just a sampling of questions from each of these topics. Okay. So what I would suggest that you do before you get to the final exam is, of course, review the lectures, just make notes on what are important concepts that are being taught in the lectures, and also very importantly, review all the assignment problems you have solved so far, the various assignment problems. Take a look at the solutions as well. Make sure you understand all the solutions to work out any of the assignment problems. And please feel free to raise questions in the discussion forum so that we can address all those questions and try to clarify your doubts. Okay, so let's make sure we do this between now and exam. And I wish you all the best for the exam, and I'll be happy to take any questions related to that. Are there any questions? If not, I will actually log off at this point. I just wanted to convey that message. I will let Ankur handle the rest of the session.
I think Sabapati is
Thank you,
having
sir.
some doubts there.
Sir, in some questions, numerical value is coming as 3 decimal point accuracy like that, sir.
Right.
But when we substitute the value for pi as 3.14, we get one value. We substitute 3.1415 like that. So some range of answers should be there, sir.
That's right. We always try accommodate a range of values. That is something that we do for all the questions. However, there might have been an odd question here or there where the range was defined relatively narrow. It's very unusual, but if you to broaden the range behavior.
Okay, thank you, sir.
Okay. Next one. Thanks. Okay, Ankur, please take over. I will log off now.
Yeah, thank you so much, sir. Okay, we were here.
Sir, I actually lost connection. I didn't hear sir telling about the.
So where, what, did you hear something or not? What Professor told?
Like they said some design of problems, like I didn't get the elaboration, like what type of design problems.
Actually,
And
this video will be uploaded on YouTube. You just follow up, okay? You will get clarity, whatever
okay,
is
fine.
here. Okay. If you have further doubts, then you can comment on that YouTube link. Also, you can ask in a question that comment box there in a NPTEL session. There it will be there. Okay. Professor will reply
Oh.
immediately.
Okay.
Okay. So we were at question number 2. So did you understood this one, or as professor told, or something?
Oh, yes. Yes,
If
yes,
you
that's
have
right.
any doubts, further doubts, so you just ask in a comment box. That will be better, because I also didn't follow this week. 11. This is question number 2. Question 3. There is a three wave mixing is called so because of what? Can you tell?
Third option.
Third option. Okay. So here what is happening? Two incident field with omega 1 and omega 2 couples with each other, producing omega 3, which again multiply couples with omega 1 and omega 2. That is called the three wave mixing. Okay. Then question number, clarity I can write down here. I think this question was quite easy. Two waves, and after that what is happening? Wave 1 plus wave omega 3, this one is happening. Then this is coupling. This is omega 3. You can say directly. Like this, three wave mixing is happening. Okay. Then next question, question number 4. In the question given below, there are two statements marked A, assertion, and reason R1 and R2. Mark your answer as per the options given below. Assertion is given, two wave mixing is not possible in general, and reason 1 is there, R1, two waves of arbitrary frequencies cannot be coupled without the help of the third wave, and reason 2 is there, it is possible in some degenerate cases where omega 2 is equal to 2 omega 1. So what's your thought about this one? What you have marked here, Anirudh? Sabapati?
This
Option
two, sir. Option
2.
both are all are
Okay. Yeah, all are correct. So when two waves of arbitrary frequencies cannot be coupled without the help of the third wave, that is the first thing. But it is possible in some degenerate cases where omega 2 is equal to 2 omega 1, in which the second harmonic wave 1 contributes to wave 2, and subharmonic of wave 2 omega 2 by 2 contributes to the wave 1. Okay. Now question number 4. This is the correct option. Here match the following. In that what you are thinking, like See, this kind of question only will be asked in the final exam. There will be no new questions. Whatever the concept here, he will answer. He will repeat the same thing in exam, final exam. Okay.
Sir, this concept I was not very clear.
Okay. This match the following one.
So like why is it that particular one? If you can just tell me next.
Okay. So first you tell me which option one what you want to choose in this WXYZ. Can you tell me? Hello, can you hear me?
Yes.
So in that what is happening? Omega 3 is generating through signal like omega 1 and pump omega 2 is giving. So what is happening in this? What concept you are getting? This filter is there. That filter what is happening? Like what is doing there? Actually, it is a frequency
Okay.
conversion.
Frequency conversion.
Yeah. So in this will be this one. Then second one is there. Same input signal is there. Omega 1 and pump is omega 3. Now this omega 1 only it is coming. Omega 2 is just was out. Okay. So what is happening here?
Now amplification.
Yeah. So particular signal is coming out. Whatever signal input is there, omega 1, that is coming out. The amplification. But why you are telling me it is not clear for you? Can you explain? Anirudh,
Not sure.
which one?
Why I
So the third one is like this oscillation is happening. Two mirrors are there, then oscillation will happen. Optical parametric oscillation because only omega 1 is coming out. Okay. If you have pump omega 3 you are giving and inside this omega 1 omega 2 are there, only omega 1 is coming out because of oscillation. And the third, this fourth one is down conversion here. Do you have any specific question for this? Frequency conversion. Okay, then we for question number 6. If you are not satisfied with the questions, the answers also, you can type on this discussion forum. Okay. So we'll discuss with professor also and let you know. You have main exam, in that you have to do properly. Okay. So for that only you have to study this all things. Question number 6. A WDM optical communication system is operating at 100 channels, each at a different wavelength. The system is designed to support a maximum of 100 channels, but due to increasing traffic demand, the system is becoming congested. As a result, some channels are becoming overloaded and experiencing packet loss. Which of the following phenomena can be used to overcome this issue? So there are 4 phenomena are there. So Kerr effect, cell-phase modeling, cell-phase modulation, four-wave mixing, cross-phase modulation. So, can you tell me what could be the answer here? Yeah, correct. So the solution is here written like, to mitigate the problem of congestion, the network operator is considering using FWM, okay, four-wave mixing, to convert some of the overloaded channels to different wavelengths. This would allow the network to support more traffic without sacrificing performance. Okay, so four-way mixing is the phenomena that can be used to overcome this pocket loss issue. Okay. This is question number 7. Now this question number 7 is that you are working on a new type of medical imaging device that uses pulsed lasers at a wide range of wavelengths to image blood vessels. This device has the potential to revolutionize medical diagnosis and treatment, but it requires a laser source that can generate pulse lasers at a wide range of wavelengths with high efficiency and reliability. Which of the following phenomena can be used to overcome this issue? So optical parametric amplification is there, cell-phase modulation is there, four-way mixing, and optical parametric oscillation is there. So which of the phenomena can be overcome this issue? Please tell me. Okay, OPU. Optical parametric amplification. Okay, OPU. So in that, what is happening, that optical parametric amplification is a process that uses a non-linear optical crystal to transfer energy from a pump laser to the signal laser. The signal laser is amplified while the pump is weakened, so the microscope can produce clear images. Okay. So this is the option for this. Now we'll go for question number 8. A mode-locked laser is used to generate a train of ultra-short pulse for an optical communication system. The pulses are transmitted through a long optical fiber, but the dispersion of the fiber causes the pulses to broaden. Which of the following phenomena can migrate it? Here also, like cross-phase modulation is there, cell-phase modulation is there, optical parametric down conversion is there, optical parametric oscillation is also there, OPA. So here you tell. Okay.
Self-phase modulation.
I think, yeah, I have done some mistake here. Question number here I have done some mistake. Wait a second. Yeah, correct. Question number 20. So here what you are telling? Can you
Self-phase.
Before that, one question was there. Yeah, I have done some mistake here in this question. That option is this fourth option is corrected. Okay, OPO. I didn't check your okay. Niruddha already told this OPO. Okay, so this one the answer. Okay. So here what is happening in OPO process, non-linear optical crystal used to generate two laser pulses from a single pump laser pulse, and that the wavelength of the generated laser pulses can be turned by varying the property of the non-linear crystal and the pump laser pulse. Okay, so this process is happening here. Okay, OPO, not OPA. Okay, I got confused there. The question. It's mode locked one. SPM, cell phase modulation. Yeah, it is correct. So here also SPM is a non-linear optical effect in which the refractive index of the material changes in response of the intensity of the optical signal. When the light pulses passes through the non-linear optical material, the intensity of the pulse will cause the refractive index of material to change. This change in refractive index will cause the pulse to shift. If the chip is chosen correctly, the SPM induced chip can compensate with for the dispersion of the optical fiber and prevent pulse broadening. So here SPM is the correct option. Okay, this phenomena mitigates it. Okay. Now this question number 9 is there. So this is find the ratio of propagation length to crystal width for a lithium niobate oxide LiNB03 modulator shown in the video, given the operating wavelength of 1054 nanometer and a refractive index of 2.3. So it is asking about this ratio of propagation length to crystal. Okay, there is one equation for this formula. We can say this is L by D, ratio of propagation length and crystal width. Okay, this is width and this is length. Lambda upon R and a cube V pi. So here if we keep all the values, lambda value is 1054, R is for this you should know this reflection is here 30, R value is 30 picometer per volt. And reflection index is given 2.3. And this V pi is given as 2.4. Okay, if you put this value, then you will get the ratio of propagation length of crystal width. Okay, so here it is done, week 11. Now you just tell me, let me know which 12 assignments fiction not value, five value. Actually, okay, so this I'll check once. 5 volt and 2.4 is there. Here this Vpi is 2.4 because they have to follow the lecture. That's why they didn't give this value. All these values, the same question, exact question they have taken from there, from video. So 5 volt, I should check this one. So your question is got wrong. Can you send the link here? Now I'll check once. Can you send the link and minute? You can tell me what is the timestamp so I can find out 5 volt is there or not. Actually, you have only 4 videos I think in a week. So you have to follow all the videos, and after that you give the assignment. Okay, without seeing the lectures if you do, then it will be wrong. Answer will become wrong also. Sometimes in textbook something will be there and professor will be asking something else. Maybe he is solving something else. So you didn't got the halfway voltage. Yeah, I'm waiting anyway, don't worry. For week 12 assignment also you can ask if you have any doubts, because this will
So I'll send the link.
yeah, you can send in this message box itself. I'll find out, I'll figure it out.
So you continue. I'll send the link. Where it goes.
Can you text? Your voice is not properly audible.
So my internet connection is not good, so the video is not loading for me.
Okay. Do one thing.
So you continue. I'll send link when the internet goes.
Yeah. Okay. No. So till that, if you have any doubts about this week 12 also, let me tell. Let me show you questions. Then tell me the doubts, whatever you have. In this, you have any doubts? This question you have solved already? No, don't give answers. I'm just asking, did you solve or not, like that. If you have any confusion, then
Yes.
Okay. Yeah. Because it is live. Almost 2 days it will be live. After that, we can discuss about this also. Maybe I'll try to take another final class. Possibly Suresh also will join me.
That would be nice.
Yeah. but please follow the video lectures. That will be very useful for your examination purpose. Okay. Yeah. Question 2. Here this instruction is given for all 3 questions. Did you follow the lecture, and after that did you solve this? Just tell only yes or no. Maybe
Yet to solve the fourth.
Okay. Deadline is only 2 days are there remained, I think. Today is 16th, so 18 it will be. Deadline will over. Okay. So just try to solve this. If you find this lecture itself, you will get all these questions answered. Only two lectures are there in the week 12, and questions are quite easy. Okay. In this one also you can ask. I think I went quickly. Okay, yeah. Question number 5. So you were solving these questions or already solved? Sabapati, did you solve this question? All these week 12 assignments did you solve? Anirudh, how many you have solved till now?
This one I didn't solve. Yet to solve.
Okay. Yeah. Follow the lectures, it will be very easy for you. Okay, please solve it. This is also very easy. Actually this assignment I have designed, so maybe whatever the questions are there, all are from video professor's lecture. So you just follow that. Okay, Anirudh, I was asking you one thing, like something you were asking that time. What was that in the week 12?
That Pockels effect, like
Core effect was
there are like 2 values given.
okay. Can you type better? I can understand. Okay. This is also very easy question number 7. Just you have to tell about the scattering coefficient at room temperature.
I posted that link. At this point, only sir took 5 volts. That's why I took also that.
Can you tell the timestamp?
Cannot
With the time pricing. If you click the link, it will take to that
yes.
particular time.
Okay, 5 volt he has taken. Right. Okay.
roughly 1 centimeter. Just 1 centimeter of
Here
separation between weight, right?
so L is given 1 centimeter. Coming. Okay, let me check this once. did you follow this? Is it for silicon oxide or lithium niobate oxide? Okay, I'll let them know. Maybe some issue was there, I think. Okay, Aniruddha, I will do one thing. I'll just convey this message to professor. That will be better. If it is some mistake is there, then maybe it will. This question will be.
Yes, sir.
The answer will be changed, I think.
Yes, because I think it might be my mistake also, because there was like 2 values they were taking. One in sir, I think maybe as an assumption he might have taken sideways. And experimental video 2.4.
Yeah.
So at that time I didn't know that I had to take the 2.4 mark instead of 5. So
Yeah. Okay. Okay.
if the questions was a little bit more clear, saying which video they have to look for and what experimental value you should take, or it would have been nicer, because I didn't know where to find the.
Yeah. Maybe I'll ask once why they have done like this. Okay. So okay, you ask in a comment box, then I will reply, or whoever the corresponding PA, he will reply for this. Okay? If it is some problem is there in this question, then we will just modify this question, or maybe we will try to give the both answers, because if 5 volt is there, half phase voltage, then we'll try to do something.
Okay, sir.
Yeah. Here question number 8, 7 we have done already. 8, I think these all questions are quite easy. What do you think about this?
Yes.
Question 8, question 9. We can do it.
Yes.
Okay.
Yeah, they're fine, sir.
Yeah. So here maybe some issue will be there to solve. Just solve properly. Maybe some values you can do. Unit conversion may be possible. I think most of the questions are done like this only. Whatever professor has given in lecture, same questions I have kept here. Okay.
Yes.
If you have any questions about this, let me know. Week 11 and week 12.
Sure.
Yeah. Okay then guys, we'll wind up this session here itself. Maybe if it is possible, I will extend one more class, live session. Okay. Otherwise, this will be the last live session for this course. Okay. This time. It's very easy questions. Like you don't have to worry about the proofs. You just follow the videos. Only 2 videos are there. You can spend only, maybe you can follow within 2 hours you can finish it, and each and every answer you will get there. Okay, you don't have to worry about this thing. Yeah. since it is a live, then I can't solve this thing. Yeah, thank you so much. Thank you so much.
Thank you, sir. Thank you so much. Okay.
Okay, so I will wind up there here only the session. Best of luck for your
Sure.
examination. Okay, final examination you do well. Okay. Okay, guys. Let me. If you have any doubts, let's ask in a discussion forum. Also in a YouTube comment also you can ask. Okay, professor will see those things. So I'll wind up here. Okay, thank you so much.